Thank you. Over to you, Ryan.
Thank you. Hello, everyone. Just give me a second while I set up my screen for presenting.
Ryan, your voice is very low, actually.
Is it any better right now?
Yeah, perfect.
Yep, it's much
Okay.
better.
All right, and you can see my screen?
Yeah, Ryan.
Yeah, Ran,
Yes,
we
we
can.
can see.
Okay.
Yes, we can.
So I'll start with first a little bit about myself. So I'm Ryan. My primary job is working in cybersecurity, but I use Splunk a lot. I've been using it for probably about 5 years or so. And I do use it a lot for security, but what I'm going to be talking about today is just a home use that I use Splunk for looking at some IoT data for IoT devices I made myself. So I have a couple of examples I'm going to show just of the devices I've made and what I'm using Splunk for to show data from those devices. So first off, where am I running Splunk? So everything I'm showing today will be run on a 2 CPU Splunk instance that's running in Azure. So the specs are pretty small, but the instance I'm running is also pretty small. So here's just stats from Splunk, from the Splunk Management Console on the usage of that environment. It's not much, though. Really, the small CPU is fine for the Splunk environment. And it runs in Azure, so I don't need to worry about anything in my house or having to maintain a server here. So on to the IoT devices. So I have a few IoT devices within my house. So over here on the right, you can see one of these devices. This is a older Raspberry Pi 2 that I had just laying around my house. The Raspberry Pi makes a great IoT platform just because it's low power, it's small, can fit in a lot of places. This one right now is just kind of sitting on a shelf kind of in my living room. And what I use this one for is it runs a service that I've written in Python that collects temperature and humidity status, as well as will turn on my Nest fan if certain conditions are met. So in doing that, just recording that data, I wanted to have a way to view the data because right now you can see here on the left, this is the format my data is coming out in. So it's just a basic comma delimited file. And it's really hard to make means out of what that data is just sitting there like that. So the data is comma delimited because that's a very easy way to get IoT data out. It's really easy to create and really easy to process on Splunk side. So I send all that data to Splunk, which will look something like this. So here's going to be hopefully a live demo. And you're able to see this tab, everyone, correct?
Yes, we can see.
Okay. So this is the output of that data that I was showing on the screen earlier, just that basic comma delimited data. And so what these graphs just show is the temperature of my house where it's being collected, the humidity of my house, as well as graphed over temperature. And then I also have a Nest, and I pull data from the Nest also into that same CSV log file, so I can compare what I'm seeing versus what the Nest is seeing, because the devices are in different parts of my home. You can also see here at my house these dips. That means my air conditioner is running. So that's actually taking a look at the data. Same thing with this little bar graph down here. You can see that when my AC runs, my humidity goes down, and then as well as the temperature. So we can take a look at the actual data in Splunk. So really basic SPL. just time charting a bunch of data. And then the raw data is, once again, just that CSV data that I'm writing out to a log file. Now, this particular log file is being collected by Splunk Universal Forwarder, just because that's a very easy way to get data to Splunk when I have a full operating system. So once again, the process is really easy of a Python service writing CSV file from a sensor to a file, and then UF sending it to my Splunk environment. And in turn, we have these graphs. So that is my first IoT device use case. So I have a few more devices on my home network. So this one right here is an Arduino Uno Wi-Fi. This device is a little bit harder to see because it looks like a rat's nest up in my garage. But what I use this for is opening my garage door from my phone. So the Arduino Uno runs a web server and looks for a specific command. Once it receives that command, it will open a relay, which is the little blue device that you see up there. And that opens my garage door, so I don't need to carry a key or another garage door opener with me. So this is an Arduino is a microcontroller, so it doesn't run a full-blown operating system like a Raspberry Pi. So in this case, I don't have the ability to run a Splunk Universal Forwarder. So these logs are collected by a raw TCP. So here will be another live shot of my Splunk environment. So this data is a little bit less detailed, only because I'm capturing just an action of the garage door opening. In this case, it's being written by a raw TCP. So the data itself is really basic. So if we look at the raw data, it really is just a timestamp and then an action. But this allows me just to keep track of the comings and goings of when that device is being used. What I also have set up, but I don't think I have a way to show it, is when this is triggered, I have an alert that sends me an email. So I get an email as a text message to my phone every time this triggers as well. So it's just another way for me to be able to track when the action is being triggered. So once again, raw TCP is a very useful way to get data to Splunk if you don't have a big, fully blown environment. Raw TCP literally just takes whatever is in the TCP stream and puts it in the Splunk database. So it's really lightweight and really easy to get data in for things that aren't really a full OS or doesn't support a universal forwarder. So once again, here's just a view of the data in Splunk. So I have a few more IoT devices, as the topic kind of suggests. This one is a Raspberry Pi 3 running a PiHole. So this one is an out-of-the-box PiHole. So for those of you who don't know, a PiHole is a DNS server that runs on a Raspberry Pi, and it automatically gets lists of bad or malicious domains, so that if you go to do a DNS lookup on those domains, it will give it a loopback address instead of the address of the malicious website. So it kind of acts as a network filter without having to have a lot of expensive equipment. So I run this on my home network just so I can keep what I browse and what my wife browses from going to malicious or bad sites. So the one big thing about a PiHole is it generates a lot of logs. And because there's not a lot of storage on a Raspberry Pi, and that storage would be written to fairly often, I'm writing all my logs to a temporary file system. So this is out of the norm for a PiHole setup. So what I have in my fstab file is this line right here, oops, the tempfs line, which creates a temporary file system in memory on the Raspberry Pi, so the logs are never written to disk, or in this case, SD card, which acts as disk. So with a PiHole, what I needed to do after creating that temporary file system was just change a couple of the PiHole configurations. So I made a new temporary file system. In the PiHole config, I point the log there and tell the log to log extras. In this case, also because it is a full-blown operating system, all my Raspberry Pis run Debian, or Raspbian, which is a variant of Debian. This also uses a Splunk universal forwarder to collect data. And the data is just the PiHole log on the temporary file system. So this is a screenshot of some of the data, and hopefully we'll have a live demo working. So yeah, this would be a graph of my DNS traffic over time from my house. So you can see just kind of like when activity happens just by looking at this graph. Now I have a few more demos with this data. So what I'll show first is the raw data itself is really just typical DNS log data. So you can do with it whatever you would do with typical DNS log data. And I have a few of these dashboards here, but I'm going to show the next IoT device I have before I go into looking more at those. So my next IoT device is just my standard router. The router itself produces syslog, and I also collect ARP data from that. So I combine all this data along with my DNS data to just show what's on my home network. So once again, this data would be collected agentless. Syslog is sent via UDP, and the ARP data would be collected via raw TCP, just like the other data. I'm doing this because the router itself, which is the black box on the right, is just a small Linux ARM box. It's not really meant to run anything full blown. So it's just running its basic OS and sending data over UDP and TCP. And that produces a graph that looks similar to this. So this data is really just helping me maintain information around what's going on my network and who's connected. The data is dynamic, just simply because anytime someone new connects to my network, I'll get an ARP entry for them. So I'll be able to know who's on my network. I can make a static lookup list, which is what I do to compare for what's there that I don't know about. And then I have one more chart data up here, which is just my DNS traffic over time. So that really goes over my IoT uses in my house and how I look at that data in Splunk. That's all I have for the presentation. Are there any questions?
Hello, Ryan. This side, Rafiq. I wanted to know, or very much curious, on the thing is just like as you presented, most of the IoT devices are in static right now. So you were sending a log to the Splunk, that is perfect. But any of the devices which is means in dynamic in state, if I say that the IoT devices is moving from one location to another, then how it can be means onboarded to the Splunk.
Well,
Just curious about that. That's it.
So if any of these devices were dynamic, so my Splunk environment runs in the cloud. So any device in the world should be able to connect to it. So if you're using just a basic DNS entry and you have your environment set up to point to that DNS entry, you should be able to get data from any device as it moves with an internet connection. Does that answer that question?
Thank you, Ryan.
Hey Ran, Nishant here. So, when you say like you'd send data to UDP and TCP from devices, like I understand, like if you have a operating system, you can write any script or send data through UF. But like for the, let's say your router, how do you configure to send the data to your indexers?
So the router supports it natively for syslog. So UDP is just a native function of my router. So all I had to do for that was enable a 514 listener. So listen on port 514 UDP to consume that data. For the ARP information, I actually run a little, it's a little bash script that runs on the command line of the router, and it just writes out that data to raw TCP. So it's literally opening up a raw TCP socket just to send the data out.
Okay.
It's a very, very simple connection. On the Splunk side, I literally just listen the data that's sent by the client is really everything. It just takes that data and puts it right into the index. It uses a new line or a closed connection as an event breaker.
Okay. Thanks, Ran.
So then, I would like to see like how we have configured the devices. Like I just want to touch base, like how we are configuring. Like we have lot of devices you are using, router and the tool and all these things. How we are configuring these things.
I mean, how it's configured within Splunk?
In Splunk and before data comes in the Splunk, how what we are doing actually from the device in device, what type of setting we are doing, something like that.
Sure. So here's one of my TCP listeners. It is just straightforward a TCP connection. So, or a TCP listener. So there's nothing special about what I'm doing in Splunk. Let me go see if I can bring up some of the basic web server code for like the Arduino. Give me 1 second. So when you're asking about writing over to raw TCP, you should see another. So this is just a set of code right here that I use to record or write the garage door information. So it's incredibly basic information. So just the basics of I create a variable that has the date and time of right now, and then I just give it a string of, hey, garage door is opening, which is the data we saw in Splunk, and then a new line here at the end, a carriage return and new line. Then to write the data, it's literally a raw socket and putting that data and then closing the connection. So when I say that it's very simple, it really is the most basic way to get data to Splunk. It's just posting some ASCII data with a raw connection to the Splunk environment. So it can be done in almost any programming language out there, but it makes it very easy if you're just posting basic raw data like this. Does that answer that question?
Yeah.
So Ran, Sumit here. Just a doubt. So the one that you're showing on the screen, this one is coming from the Raspberry Pi that you showed, one of your IoT devices, right? Is it
No,
coming-
this particular one, yeah, this one is used with the Arduino. The
Okay.
Arduino calls another server, and that's what calls this right here.
Alright, because this looks like a piece of code, so I was wondering if this is written on some sort of operating system, or is it?
So everything I wrote for the Arduino, I wrote in the Arduino programming language.
Oh, right, okay.
I wrote it a while ago. It's a very basic web server. The web server was part of a library.
Okay.
All the code around opening the garage door is very simple. There's only a single relay, so the process for that is literally just send a signal to a GPIO pin to hold open a relay for 500 milliseconds and close it, and then post out data like this. But that was all written in the Arduino language just because it had to go on the Arduino microcontroller. I think everything else I've done has been written in Python.
Oh, right, okay. So I was not aware about Arduino a lot, so that's the reason. But I'll go and have a look. Sure. Yeah. Thanks for the explanation. Yeah.
Yep.
Hey Ryan,
And
this is Abhishek. Have you used Circuit Python in this particular use case, or was it some normal libraries, including networking and SIG-IO libraries?
So everything I've used is a standard library. The only thing that I would consider unstandard was the temperature and humidity sensor for the Raspberry Pi. The library needed to access that data came from the manufacturer of the sensor. Other than that, everything is just what's available, open source on the internet. It's all really basic data. Most of the data is really just writing out to a file system in a CSV format.
Thank you.
Any other questions? Okay, well, there's no other questions. That's all I have to present. I would say if anyone is looking to have better network security at home, running a PiHole is actually a really good way to provide basic filtering on your home network just to make it a little bit more secure. Raspberry Pis are really cheap. They don't really draw that much power. And the PiHole itself is really easy to set up. Same with if you want to get the logging out, those two configuration changes I showed earlier, really easy to make to get logging to a temporary file system and then up to Splunk. So it's something I would really recommend if anyone has time. But that's all I have.
Ryan, can you post the link of PiHole for everyone so everyone can access it?
Sure.
Cool. In the chat window, so that will be handy for everyone.
All right, well, I don't have anything else. So I guess thanks for everyone for coming to listen to me talk about some of my home IoT.
Thanks, Ryan. It was very interesting.
Yep. Thanks, Ran. It was indeed interesting, and thanks for coming.
Thanks, Ryan.
Yeah.
It's a great session.
Okay, thank you guys for joining in. So if you have any questions, you can put that question in our Slack channel. So if you need any help to set up these things, so you can have a touch base with Ryan over LinkedIn and over Slack and all these things. So these are some useful resources. So you can have it. You can have a look. So about user group events, and we have a conf coming up. 20 conf is free for everyone. You can register over there. If you have queries, you can go to Splunk Answers. We have dedicated channel for Splunk Slack, so you can go, you can join, and you can find a lot of stuff. So there are a lot of channels related to admins, related to IT infra. You can for noobs and all these things. So you can go and explore. You can ask questions. You can get a response within a day or within an hour. That's like so for some support and services, you can go to Splunk website over here, and all the learning and development documents you can find over here. We have Splunk, we have Splunk based dev blogs and docs. So I would like to thank you each and everyone who have joined the meets, and I would like to thank for the insights over here. So we are looking forward for your feedback. You will get a form, you will get a poll from that automated mail from the Splunk in an hour, and you can access this recording. So we'll post in a LinkedIn, we'll post in a Slack, and you can see the recording how what Ryan has presented, and we'll drop that presentation also. So thank you all. Thank you very much. We'll see you next time.
Thanks, Rohit, Nadeem, and the complete Pune user group team. We congratulate you on your first meetup, kickoff meetup, and I'm sure that this group is again going to do wonders with your upcoming meetups. And we have also the support from the Splunk community. So while we would be having the next meetups, we would certainly be partnering on Splunk for Rookies workshops. I'll keep you all posted. So congratulations to each one and the whole group of Pune user group team. Thank you.
So thank you, Abhishek. Abhishek is from Hyderabad, Puri, Hyderabad user group. So big shout out to him and Nikat. He's not available today. So both of them helped a lot to set up our meets and how we have to proceed. And they have helped each and everywhere when we have questions, when we have doubts. So big thank you to you both, Abhishek and Nikat. Thank you, guys.
Yeah, thanks, Abhishek. Thanks.
Thank you.
Thank
Bye
you.
bye.
Bye.
Take care.